this is so nerdy, but like that Eevee Pokemon where it's like you give it a water stone, it becomes like a Vaporeon. If you give it a fire stone, it becomes like the Flareon or whatever. That's so nerdy. Wow. But the different types you like pass to the StateT like has different effects. I mean, there's any number of cartoons or like superhero kind of shows where it's like, you know, there's like these different modes of operation, or you know, it's like once you apply this thing, then like the powers change, you know.
Right. Yeah, it does feel like that.
Hi, I'm Logan, and I've been teaching myself Haskell by going through this excellent course called the FP course. This time, my friend Pete was graciously willing to help me go through some of the StateT module exercises. You can find a link to all the FP course videos I've done so far, my stream, Pete's stream, the course, and my progress in the code, my solutions, in the video description below. So be sure to check that out. Thank you so much to Pete for joining me. It was super fun, man. And thank you for watching this. If you've been liking the series so far, please consider giving the video a like and be sure to subscribe because I'll be doing future FP course modules coming up. I'm new at this whole YouTuber streamer thing, and I've been working hard to make each video better than last, so I appreciate your patience. Without further ado, let me introduce you to my friend Pete, and let's solve some Haskell problems.
Okay, I'm just gonna start over. Hello, welcome to the stream. We had some audio issues, but I'm here with Pete. Pete is a friend I made on Twitch, basically, and the functional programming Slack, and he agreed to do some Haskell problems with me. So thanks for joining the stream, Pete. Appreciate it.
Thanks for having me.
Yeah. So
My pleasure.
one of the things we cover is Pete works at SimSpace, which is an employer of Haskell developers, and they are hiring. So I just wanted to throw that out. And Pete has been working on a PureScript course. It's called PureScript by Example, I believe.
Yep.
PureScript by Example, and going through some similar kind of content. And we thought, hey, let's get together and do a stream together. So yeah, so what we were talking about so far is we're doing the StateT module of the FP course, Haskell FP course, and we just implemented the Functor instance for StateT. Let me just do a quick test on this Functor test. Okay. I think I'm using the right one. There might have been a functor test for source test StateT test. Okay, cool. Yeah, so should we do it? Can we use first right here? I mean, it's a similar thing, right?
Yeah.
So that's just a drop.
I wonder, I think, yeah, and I think HLint may even suggest it.
Yeah.
Oh, it's suggesting bifunctor at first, which is funny. Interesting.
But what you're saying is like they're basically
they're equivalent. Yeah.
Okay. Wonder if I do this quick fix thing, if it'll work.
In this case, they're equivalent. I should qualify.
Oh, okay.
As far as I know, I think they're maybe always equivalent. I'm not sure.
Okay, the quick fix thing didn't work. But first, so that should just work then. Oh, first.
Yeah. Do you have an F? Oh yeah, yep. And then I think, is it just complaining about that? Yeah.
I just tried to use the command tab to change to my terminal, but it's in the same. Okay. Test functor test. Okay, cool. That still passes.
Nice.
So then we probably don't even need this expression.
Yeah, you can just do that inline.
Cool.
And you kind of keep reducing it. Yeah, I don't know. It's like where do you stop?
Yeah.
I don't know. Like,
would you leave it multi-line like that, or would you inline?
I like let
being on two lines
blocks to be, yeah, but
yeah, okay. Let's leave it
I'm not an authority.
Okay, Monad, let's do it.
Wait, don't we have to implement applicative?
Oh, yeah.
All right. Yeah, this is interesting. I'm not gonna give you too many hits.
Okay. Implement the applicative instance for StateT sk given a monad k. Ooh, okay, so it's being tricky. So back in the monad course, there was a exercise to implement apply with bind and fmap, which I'm going to use. I'm going to go reference that. Yeah, so we did this double splat operator just as an exercise. Yeah, witness that all things with bind and fmap also have apply. So we bound this monadic value and then that had a function inside of it, and then we fmap that onto this value.
Nice.
So I might even copy this over. Oops. Well, I guess I need to do pure first.
Yeah, pure is a good world. I mean, it's like the relatively easy thing to implement for applicative, right?
Okay. So I have this A, but in order to construct a K of AS, I need to use pure. It's like pure inside of pure. Or is this going to be like a recursive?
No, it's not recursive because it's
a type inference.
Yeah, so it's like GHC knows which pure to dispatch, like to. It's not like dynamic dispatch, I don't think is the word, but like it's like looking up.
Which
it's like finding
implementation of pure, like.
Yeah.
Wow, that's that feels like magic to me, like. But it makes sense. I mean, we have this A and we have this S, so then we know we can, and we know that K is a monad, which must also be applicative, so that we can construct one with pure. So sorry. So I wonder if there's usually not a test for just pure, but maybe I could say applicative, and then hopefully one of these passed. Yeah. No, it failed.
Failed. Wait, what?
Pure instance state TSK. Well, maybe I'm wondering if we need to implement both for the test to pass or something.
Maybe. Well, I'll look at that test in the meantime, and while you're working on that.
Okay.
Because that's curious.
Okay. I think what I'll do is for the apply one, I'll do pattern matching. So I can pattern match on this. Scab, SKAB.
Sounds reasonable.
Okay. And then I need to implement a new StateT. Here. So yeah, this first one is the scab, sk of a function from A to B, and then state ska, and then we were trying to construct a state T skb. And then I've added this S here and put it in a type tool, so we need a KBS.
Yeah.
And
this is tricky, but like if you think of so you got S to KAB. If you just had a K of A to B S, and you had a k of a and s, well, actually, maybe to make it even simpler, if you had a k of a to b and a k of a, what could you do to combine them?
So, yeah, if I had a k of a to b and a k of a, then I could apply them. Right? Or what I think, because we're implementing apply, I think I probably, because we know this k is a monad, I'm going to have to bind one and then fmap. Because of, let me see if I can get that back.
Yeah, that's actually the correct road. I was tempting you down the wrong path.
Okay.
But like, just because that's how I like. All right, it's interesting that you need a monad instance instead of an applicative instance for k, I guess is what it's what I find interesting, and I still don't really
Okay.
but
so you're saying like,
if you only had an applicative instance for k, you could write something here that type checks, but it would be like lossy. It would like we could go down that route if you want to, or we could just know that we have monad and we can bind.
Yeah, let's get this implementation first, and then maybe explore that after. So
sure.
Yeah. So my instinct is to say I'm just gonna say let x, and then I'm gonna apply s, or apply scab to s, which gives me a k of this k to a to b s, k a b s, and then if I also, but I'm probably going to need the s that came out of here to apply to the ska, right? That's tricky.
Yeah, so you might not get too far with just doing let binding. I'm not sure, actually.
So maybe I just need to jump straight to like bind, and then this should give me KBS, I believe. Okay, it doesn't like this, but the to do is a KBS. Yeah, so am I on the right track here with bind? Let's see. Maybe
I'm honestly not sure. It's been it's been a while since I've. All right, so you have a
Let me
K
throw
of
one more set of parens. Okay, no, it's still mad about this.
Oh, because you need to supply s to scab, right? Sorry.
Oh, you're right. You're right. So then I can bind on s, like scab applied to s.
Yeah, because now you have a k of.
Right.
Which, when you bind, yeah, what is the type of cabs there?
Cabs.
Because I think it's maybe misleadingly labeled because
because it's not. Well, there is no k. You're right. Yeah. I mean, you were right to ask me that. So now I have an AB. So then maybe what would be good to do is to just pattern match here so that we have our, and maybe I'll call that A to B. And we have our S prime now, which I think what I need to do is say ska applied to S prime, and then that should give me an A to S double prime.
That looks right.
It's a lot of parens.
Yeah, I think everything kind of associates to the right. Not everything, but I mean.
So I can probably remove these. Is that what you're saying?
Yeah, I think so.
Let's see.
You might need, yeah, one final one. Is it happy with that?
I think so. Everything's a little laggy. Okay. That seems to compile except for the type toll. So then we still need a KBS, but now we have this A and we have an S double prime. And I can get my B by applying AB to A. That should give me a B. And then I think I just pass in this S double prime. But then this whole thing needs to be a K.
Right.
So I guess I could do pure, but no, but that pure only lifts it into an applicative, or will that still work? I guess.
Yeah, why wouldn't or why?
Yeah, I would.
Yeah, why wouldn't it work?
Yeah, I guess I was confused there. So let's see. Because you're not constructing, like with pure, you're not constructing a monad or an applicative. You're constructing like some data type, right? Like a list or something. That was like
yeah, you're kind of like
terms.
lifting a value into context, I guess. It's kind of like maybe the best way to describe pure. So you have basically, I don't know. Yeah, you have a BS, and you want a KBS for some applicative K, and like pure does exactly that. Yeah.
Yeah. So that is the right implementation of pure then.
Yeah.
Okay.
I can't think of any other way to do it either. Yeah.
Okay. Wow. Okay. So then you were mentioning that if this were only an applicative and not a monad, then we would run into problems. I'm kind of curious to see what that looks like.
Sure. Yeah. So, and it might tie in something that I think came out like somebody was mentioning in one of your earlier streams that I didn't realize I didn't know what the name of it, or there's something that I had seen. So like, and all right, so this is a little bit of me talking out of my ass, but like, so I think that like Connor McBride introduced applicative, which the applicative type class to Haskell, and like it came after Monad. But in the paper, it was like him and Ross Patterson or somebody like, anyways, it was, he co-authored the paper that like introduced applicative functors, I guess.
And that was like relatively recent, right?
I think so. But he talks about this like this idiom, or like applicative functors, I guess, were originally called idioms. I, again, might be talking out of my ass. But there's this common like pattern, I guess, right? Where you have like, some kind of function or constructor, and then you map that into your context, and then you have like other values like MA, MB, MC, like however many arguments this thing takes. And this isn't going to type check right now, but like, you could have, so we have a SKAB, like we could do SKAB S, SKAS, and then this something takes an A to B yeah, it takes an A to BS and an AS returns a BS. So if we try to implement this, am I confusing myself here? So let foo. So like foo is, I shouldn't have gotten rid of that. What was it? This, we have to implement this. Oh, probably can't see the IntelliSense, but I just copied the signature. So, oops. Oh, geez. I'm still like learning Vim. All right, so we have to implement this.
Right. Because SKAB, yeah. The AB. I Googled applicative functor, like the wiki page, like it cites Connor McBride's paper and Ross Patterson, Connor McBride from 2008. So
yeah, it's relatively recent. Yeah,
that's really
crazy.
kind of wild to think that it's that recent. And so that's why there's stuff like lift A2 and some weird naming stuff in Haskell, because applicatives were kind of like added after the fact.
Yeah, and like sequence A instead of, and like sequence and sequence A and sequence are like the same thing, but like sequence is weirdly like more specific. Like it requires a monad instance.
Requires a monad, right?
Yeah, I might not be doing this right, but all right. So yeah, so this is S, right? All right. So like you end up having to, because you can't thread the state, this like S through, you end up having to like choose, oh yeah, and this is also shadowed, so S prime, S double prime. You have to like choose which, wait, what, oh yeah. You have to choose which one, like you end up like ignoring one.
Okay.
But so,
let me think through that just so I make sure I'm following. So because SKAB once applied to S is like a this A to B S tuple, but it's in some context, right? And then
yeah, down here it is, yeah.
Right, and then this SKA applied to S is also an AS pair. It's an AS pair in a context. So if you apply it, because but then wouldn't apply have to be implemented for the StateT?
This apply has type. I wonder if I can annotate it. Oh, can I do this? Like, probably not. But no, I can't do that. But like this apply has type k of a b, k of a to b.
This thing
to k of a. Close. So this apply has type k of a to b, k of a, b. So you've got.
So is that like apply for the like tuple data type? Or what is k in a monad there? Oh no, because k, sorry, not tuple.
K is your applicative. If you only had an applicative instance for k, I'm kind of like overloading A and B here. Okay. And I think I'm frankly confusing myself a little bit because but
this is the type of apply for like instances of apply.
Yeah, I might just like, just change this to like X and Y or something. Okay. But this K is specifically
an applicative.
This K, it's this K. Yeah, if they were like scoped, this should work for all X, Y. I don't know if this is maybe getting into the
Yes,
weeds.
like
But basically,
yeah.
basically, like you can't. What's interesting is like you need the monad instance for K in order to like not lose
Sequence of the effects, basically.
Yeah, in order to like properly,
Yeah.
yeah, in order to like not lose the S, I guess. Yeah, and like I'm still struggling to wrap my head around it, but because otherwise you would have to like choose which S gets used here, and I can really only reason about that like from the types. I don't really know,
Yeah.
you know, what that means philosophically or whatever, but
Right.
but yeah, let's put it back to
Okay. No, that's an interesting discussion though. So yeah, for anyone just joining, basically we were discussing, I'm curious if there's anyone in chat that has thoughts about this. So we were just discussing for the StateT data type to implement this to implement the applicative instance for StateT. This K actually has to be a monad. It can't just be an applicative. Or it would compile, but it wouldn't. I guess it wouldn't follow the applicative laws. Is that what you're saying?
I don't even know if it would break a law or any of the laws.
It would just be a different implementation.
Yeah, it just, I guess it wouldn't do what you'd expect state to do.
Interesting.
Yeah, I mean, if anybody know, like, I'm curious too, like what, if it might break a law, one of the laws, I'm not sure.
Okay. Yeah. Maybe someone out there in the internet, on the the World Wide Web will tell us. I think if we spend too much time, then we're not going to get through very many of these. Yeah, but no, that's interesting. Maybe let's try to tackle this monad instance. So then we have this. I guess I'm just going to call it F because these names are getting kind of wild.
Mm-hmm.
I'll call this StateT of X maybe, and then I need a StateT, and I'm gonna just throw in the type tool.
Mm-hmm.
Okay, so we need a KBS like usual, and have an S. We have this X, which takes an S and returns a KAS. So I think I'll do what we did before and say let KS equal X applied to S. And to do, whoops. KBS, and then so now we have this KAS.
Mm-hmm. You have an S. Oh wait, that doesn't help you.
I guess, yeah. Maybe starting by constructing this thing was wrong because once I call this F function on an A, we're gonna get this answer back. So,
which part do you think is?
So I need to return a KBS.
Mm-hmm.
And I know I'm going to have to call this F function eventually.
Mm-hmm.
Which,
so you need an A somewhere in scope, right?
Yeah, I was kind of getting ahead of myself. Basically, I'm going to need to get this A out of this X value, and then pass it to this F function. But then that's going to give me back a StateT, which I guess I could then run, but it feels like I'm already building this StateT. You know what I mean?
Right.
Or am I thinking about it the wrong way?
I would It does make it so much easier to write the applicative with the monad constraint, and you can use do. Yeah, have you covered do notation yet?
No, we haven't, but I'm somewhat familiar.
Okay.
I'm kind of curious to paste this into see what Kumi's trying to tell us. So you can do state. Wow, this is hard for me to read. So we got like multiple do's going on here.
I think this first do is just saying
like
you can do. Yeah. Yeah.
Okay. Are the semicolons like is that Haskell syntax?
I think it's like equivalent of a new line or something.
Okay.
Essentially.
So then this should be a valid like implementation for apply.
Yeah.
MF.
Yeah, and maybe the numbers is better than the ticks. Yeah.
Yeah, for a new line. Oh wow. It just
yeah, I think it's just the white space is like a little bit is like something that's so I think you just need to indent this.
Okay. Okay. Wow. So then HLint's happy with that. Let's see if it runs. Oh, I still have this to do down here. Let's see. Undefined. Yeah, that compiles. Let's see. Applicative test passes. Wow, that's cool. So then, let me try to pick this apart. So we're just defining it with this infix. So then MF is like our StateT SKAB, and then MX is our this value, and then we're doing runState. And with do notation, this back arrow is like kind of like a bind, right?
Yeah, it's exactly, yeah.
So we did bind and we called it AB S prime, and Kumi's calling it F and S1, and then binding on runState on MX and S1 and getting back in X and S2, and then pure FX S2. Yeah, so that lines up with what we have here. But this does feel a lot more readable.
Yeah, I imagine that they'll introduce like do at some point in the course, and once I think it's a little bit nicer to read than the explicit like bind.
Yeah. When I watch the other Haskell streams, that's like everyone's using this do notation. It's kind of helps you to think about it. I guess you're kind of thinking about it more in this imperative way, almost like this is an assignment.
Yeah.
It's interesting. And then isn't that why Haskell has this like return function? It's not in scope, but
yeah. Oh, why is it's not in scope?
Yeah, I don't know why it's not in scope. Kumi says it's better to be writing with the explicit binds at the start. Oh, okay. So maybe it's better to learn with the explicit binds.
Yeah, it's hard to say. I don't know.
It just feels like magic.
Yeah, probably, and it's probably good like to get. I mean, it seemed like you were able to kind of to understand how it desugars,
right?
But I think it's good practice to take something that's written with bind and translate it to do, and then like vice versa. But it seems like you got that down. So
Yeah. Okay. Cool. Yeah. Thanks for sharing that, Kumi. That's helpful. Maybe. Yeah. I'm really curious now if we like change this monad thing to applicative and like run the tests and see if they fail. Maybe we can do that later.
I'm just gonna add a note to see future Logan.
That's cool. I'm kind of tempted to use the do notation here.
Yeah.
Maybe I think my intuition will be strong, so maybe I'll start with just the regular bind. So reorient myself. Oh yeah, let's change the undefined back into the type tool. Okay, KBS. Oh yeah, so it's a similar kind of thing, right? So if I apply X to S and then I bind, I should get this AS. I'm gonna remove this for a sec. I think I have too many parens.
Yeah, I think you can lose that one. Yeah.
Okay. And now if I apply F to A, then that gives me a state SKB. But then isn't that double wrapped now?
Yep, but that's okay because you know how to, I can
join them, right?
Well, I think that's part of what you like. Join is part of the monad class. So if you had join, then you wouldn't need to implement bind.
Oh, right.
Is that right?
Right.
Yeah.
Right. You're right. Okay. Yeah. So, do I just lose this then?
I don't think you can because you need to. I think it's okay. You can you know how to get if you have a StateT.
Yeah, I can just bind it again, right?
Well, that would be somehow recursive, right?
Oh yeah.
At that point, because it'd be
FA
bind for
StateT.
Yeah. But if you could pattern match on it. Yeah.
Or I could run it, basically.
Yeah, I'd just run it. Pattern matching on it would mean case FA of, and then you do StateT, blah, 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 and then an arrow. But all right, so what's it need now?
So
I'm not sure the best place to put a type hole here either. Yeah, it's a little confusing. All right, so runState. Do you need to provide?
So yeah, runState takes 2 arguments. So I'm just gonna do parens instead of $ for a second. So it needs an S. Okay.
I think that's right.
Okay, then that should be my KBS then. Cool. Test monad. Test. Yeah, let's go. Okay. Maybe
Swarm Collective's asking how are things going?
Oh, hey, Swarm Collective. Yeah, and we're doing StateT, so it's the next module in the chain, and I have my friend Pete here joining me, who's kind enough to pair with me. So yeah, so running so many threads in my mind right now. Wow. Yes. So what I'm thinking through is like I kind of want to challenge myself to try to write this in the do notation.
Yeah.
Let's see. I'm gonna cheat and look up here a little bit. So I think I might be able to kind of do a little bit of copy pasta here. So then instead of bind, I would put this on this side and then do this arrow.
Mm-hmm.
And then
I think that's it.
oh, is that it?
I think so. Yeah.
Oh, maybe swarm collective. No. So one thing we were talking about is for the StateT data type to implement applicative. It's our understanding that this has to be a monad instance rather than just applicative, because otherwise it might be lossy, because we talked through this. If we had just an applicative instance for K, StateT would not behave as expected, basically because we'd have to ignore one of these states. That's kind of a intense question to throw on a viewer, like right, they join the stream. Hey, explain this type theory. But yeah, just curious if there's any thoughts there.
Oh, I might be able to. Let me see if I feel like there was a explanation in the Haskell book, or like linked to an explanation. I'll see if I can find it.
While you're doing that, I'm going to continue on with this. So a state prime SA is StateT specialized to the exactly one functor. Oh, okay. So a state prime, you're just specifying the K context, I suppose. Because usually we're doing StateT SKA, and this is a StateT S exactly 1A. Provide a constructor for state prime values. Swarm Collective says, yeah, I'd like to understand that statement more. Yeah, maybe Pete can find a explanation for us. Okay, so this the state prime function, lowercase s state, goes from this function s to this tuple as to a state prime. So this is a way of constructing a state value. So I'm going to just call that f. And I think the only way I can construct a state prime is with StateT and just make sure that the output of it is an exactly one. So I'm going to do a type toll. Sorry, my dog is snoring again. Okay, yeah, so I need to return an exactly one of AS here. I'm just going to throw an exactly one here. And I have this F and I have an S, so if I just apply F to S, I think that does it. Might need to do that there. Whoops. Okay. Yeah, that compiles state prime test passed. Okay. So I think we can edit reduce this. Yeah, exactly one composed with F. Okay, I'm gonna show. That's my dog. Dog's just sitting there snoring.
Oh wait, I'm on a different screen. Passed out.
Just on this little doggy bed next to my desk, snoring away. Any luck finding the
Yeah, there's a Stack Overflow. I'm just gonna paste it in the chat.
Okay. I think the cute pup earns us a call out to for subs and likes. If you're interested in the stream, please consider giving me a follow, and Pete, my friend Pete here, a follow. If you like cute puppies snoring. Let's see. Is it possible to implement applicative StateT SM? I'm currently working on data fresh and control monad trends fresh, which define an interface for generating fresh variables. What does fresh mean? And a monad transformer which implements this interface. I initially thought it'd be possible to implement the applicative instance for my fresh TVM data type with the only requirement that applicative M exists. However, I got stuck and it seemed like I need to require a monad M. Not trusting my Haskell foo, I turned to the transformers package and was surprised by what I found in control monad transstate.lazy and .strict. It instance functor M monad M applicative state SM where pure is return and apply is app. So here's my question. Is it possible to create an instance with equivalent semantics with the following instance head? Okay, interesting. That is an interesting question. Agent Ultra says, ahoy! Ahoy, Agent Ultra. Welcome to the stream. Thanks for joining us. So let's see what the answers are. Consider that you have two functions, f, which is s to this tuple inside this, I guess I should pronounce this, m of a tuple s and a to b, and this g function s to m of a tuple s and a. If you want to create a function h, StateTF applied to StateFG. Wow, it's like getting lost here. Maybe is this StateF meant to be StateT? Do you know?
I think so.
Yeah, that seems maybe like a typo because there's been no mention of StateF so far. So if you want to create a function h.
So you've got an S. It's kind of what it's saying is like you got.
So you have this. Yeah. So in both F and G, you need to supply some state S, and then you get back this contextual tuple. One has this AB function and one has this A function or A value. So you want to get back this maybe that's not a good way to say it, contextual, but an M of SB. So you need to apply this function to this A.
So
you have
it's saying like you start out with F and G and your goal is to get it to H. But well, if you had H, or if you start to define H, then so H takes an S, but what do you do with the S? You could pass it to F, and that gets you back an M
of this. Or you can pass it to G and get back this. Is that what you're saying?
If you pass it to G, then you'd get just the M of SA, right? I don't know. I'm kind of like...
Let's read this paragraph. So how to get S out of F prime. So F, I guess he's saying from the above, you have an S, you can pass to F. So now you have this F prime, or like partially applied F. how to get S out of F prime. You need the monad. Whatever you do with applicative, it would still be in the form of ms. Right. Okay. So once you pass S to this F function, you have this M of this tuple, but you can't get this S out of this M context unless it's a monad.
Right.
Because if it's just apply, then whatever you do to it, you can apply things to it, but you can't get it out to past G.
Right.
Wow, that's really interesting. You can play with the definitions and use free monad, but for the collapse of state, you need join. Huh. Wow, that's really interesting. Cool. I think I have some sort of understanding of this. It doesn't feel like
it's a little fuzzy for me.
Yeah, it's fuzzy. But I think I've done enough like wrestling with GHCI or GHC to like understand the type errors that would or maybe it would compile, right? But then yeah, it's like how do you get this S out of there?
Mm-hmm.
Yeah. I'm gonna close this window because it's like really bright. Swarm Collective says it is stretching my mind, but I think it is sinking in. That's good. So Agent Ultra, thank you for the follow, man. Appreciate it. Maybe I shouldn't say man. Thank you for the follow. State. Okay, so we did this state prime, which is, am I saying that right, Pete? So it's like a state prime is a more specific state T. We've just passed one of the type params to it.
Yeah. Yeah. So, well, that's how I'd call it, state prime. Yeah. But
Okay.
this is kind of like how state is actually defined in like in the transformers library. Exactly. One is
identity.
like yeah.
Okay. What's that library called?
Transformers. Yeah, maybe it's not
like data transformers?
Like transformers as in monad transformers. So it's kind of like it has like an implementation for StateT. I think it's like the canonical, implementation for StateT, and like also all the other transformers that we might get to. There's like optional T is maybe T, and it looks like those
what would
are the
I
only.
Google to find that trans?
Oh, if you look on like Google, I guess.
I think it was
Or
Astaroth
Hackage.
showed me yesterday that you can do bang H in DuckDuckGo to search on Google.
Oh, nice.
It's pretty awesome. So what would I search?
I think if you just search transformers, or if you just search for StateT, maybe like
bad gateway. So maybe that I did search on Google, but bad gateway.
Sometimes Google's down. You could search on Stackage. Yes. What is it? Stackage.org or something is like the
transformers more than meets the eye. I don't know if
there you go.
That might be lost on everyone. It's the Transformers theme song. So where would I look in here?
There should be a control monad trans state. Oh, and then it's either lazy or strict.
Oh, okay. So then I need to drill down into one of those.
Yeah.
Okay.
I don't know what the default export is. It might be.
Oh, so it says identity here. I see. Which is, we implemented our own identity called exactly one. Type state S, state TS identity. Okay.
Yeah, sorry if this is a kind of a side quest, but
no, that's okay.
That ends up being like, it was kind of confusing for me. Is like there is no like state monad is just a type alias for StateT applied to identity.
I'm not sure I fully grasp that. Maybe the exercise will help me.
Yeah.
So this is a different type of run state, which takes a state prime. Let's say I'm just going to call this state, I guess. There are a lot of things called state. Can I pattern match on that?
Yes, but it's a type alias, so that the constructor is
this
state
basically
prime. Yeah.
Oh, okay.
So
I might just start out with just calling this SSA and then just keep it simple. I think I'm going to need an S. Yeah, an S to AS. So then this to do will need to be an AS, and I have this state SA. I imagine I'll want to use this function. Oh, but this function takes this type.
It does the opposite, kind of what you want to do. What you want to do, or like basically what you're trying to implement is like almost like is basically like pattern matching is
so
the
this
inverse of that.
constructs one and then this one deconstructs it basically.
Yeah.
And yeah, I guess my only option really is to pattern match, because run state would be the other way to, or I could run state on this, like use my regular run state.
Yes. Well, all right. So what is SSA? So that's state prime SA. Yeah. But like if you expand that, like
it would be this,
state prime. Right? Yeah. So you could either, well, sorry, I don't want to give you too many hits.
Yeah, no, that's okay. So maybe what I'll try first is say let X equals regular run state on SSA and S into do, and I'll just see if that even works.
So it doesn't like SSA there, right?
I guess that okay, couldn't match types. So yeah. So this isn't exactly like a type alias, or is it a type alias?
It is, yeah, it is. Okay. But I don't know. Let's dig into the error a little bit.
Okay.
I'm not sure if the couldn't match type. So expected type state SA1. I don't know if you're looking at the same error as me.
Yeah, expected type state SA1, actual type state prime SA.
Right. So the reason that it thinks that you're expecting type state SA1, is because you're using run state, right?
Yeah. Oh, instead of run state T?
Yeah, okay. Exactly.
Okay. Okay, so that seems to be happier. So X is now an exactly one AS. So I could just like pattern match on that.
Mm-hmm.
And I think I could leave that as X. And X is in a tuple. Okay. Test run state prime test. Okay, cool, that passes. So then I don't really need this let. Well,
you don't, but you'd have to do something other than before you were kind of like relying on, is there another way to get the exactly one value out aside from doing like the pattern matching?
Would I do
on the left-hand side of the
would you do like case run state?
That's another way.
What way were you thinking?
Oh, I'm not sure if it's possible, but is there like a run exactly one or something?
There is, yeah. You're right.
Okay, yeah. So you could do that. All equivalent things, right? I think.
Yeah. I think maybe I'll just leave it at that.
Yeah, I think it's fine like that.
What is HLint complaining about?
You might say that you just don't need the parentheses, and you can put the S on the other side, but like you can put the S on the other side of the equals, I believe.
Okay. Yeah, dog. Okay, cool. I think that works. I appreciate your patience, Pete. It's very kind of you to.
No, yeah. I hope I'm not like
no,
like spoiling too much.
No, this is everything I wish for and more. So, run the state T seeded with S and retrieve the resulting state. So. Okay, so we implemented exec for regular state before. Mm-hmm. I'm tempted to take a peek back at that. Close some of these files. Exec. Swarm Collective says, yeah, this looks like a great resource. Is FP course available online? Yes, it is. Let me have it handy.
It's like an Australian institution, right? That like teaches that.
I think it's changed names like a few times. So this is my fork of it. Apologies. So let me grab that actual link. So it's called SystemF FP course. Before that, it was called Data 61 FP course, and before that, it was called the NICTA FP course. So I don't know why. I don't know if Tony Morris, the guy who created it, has renamed his company or what it is, but
I'm pretty sure, and again, maybe I'm talking out NICTA, I believe is a government institution in Australia. Oh, really? It was funded. They funded teaching functional programming, which sounds kind of crazy that there'd be so maybe I'm making that up, but actually yes. It's National ICT, National Informations and Communication Technology, Australia.
So they were funding some courses.
Yeah,
that's pretty cool. Okay, so the regular exec run second on runState MS. So I imagine we'll have to do something similar. So we'll probably have to do, I mean, we have a runStateT. So
Mm-hmm.
I'm going to start from there. runStateT. Just going to call that scoff for the moment. And then I'll also put the S on this side. And then this should give us an AS, and I think we just want to run second on this.
Does it give you an AS?
No, it probably gives me a KAS, right?
Sure, actually.
So this one, runState would give me a AS, and I would return the S.
So instead of applying second, yeah, there you go. That's cool.
Pretty cool. That's pretty neat how those types line up.
Mm.
I'm going to compare them. execT. So this one, if we change this to M, then the only difference is instead of $, it's fmap, which is pretty neat. I mean, it makes sense, right? Because this is like, in some context, an fmap deals with context.
Yeah.
Is it dumb of me to feel like when I see the types lining up like this, it makes me feel like, I don't know if this is the right word to use, but it's like it's too parsimonious or too uncanny to just be like just a human invention. You know, if you were just dealing with like JavaScript or Python and it was like, or like, I guess what I'm trying to say is it feels like you're hitting some kind of bedrock, like something mathematical, you know, that's not just something somebody came up with just one day. You know, it's some arbitrary API. Does that make sense? Am I weird for thinking that?
No, I don't think it. I think that like, I don't like, I guess that was kind of like what, I don't know, like partially like why I was interested in functional programming is like, felt like it was something that was like, somehow like fundamental about like, like by learning.
Listening, I'm also just like jotting.
No, yeah. I don't really know what I'm saying, but like I guess
it's dealing with some it's like building some really powerful abstractions that don't feel arbitrary.
Yeah, it's like kind of like I guess like you can learn the basics of like category theory by way of Haskell.
Yeah, it definitely has like, I mean, a mathy feel, which is intimidating, but it's also feels really solid, you know, really solid foundation. So basically what I'm jotting down here as we were talking is since this execT was second on runState, and I just remembered that exec and eval from the regular state exercises were very similar. And I just started pasting it, and I realized that this is not eval, this is exec prime. But I think this is going to be the correct implementation for evalT, so let me try that. Oh, I should probably change this back to undefined. But yeah, Swarm Collective, you definitely should go through this course. It's really well made. I think that it's really thoughtful how they designed it. Okay, so the evalT test pass, and that makes sense to me because the regular eval is just function application, and then this one is fmap, similar to execT. So then exec prime takes a state prime, and I have a runState prime, so maybe this will be a runState prime ms, and then that should return me this as tuple, and I need so then I need the second value of that. So that's looking very similar to the regular exec.
Right.
Yeah, that passes. Let's run this in the terminal. I haven't been doing that. Let's see. Huh. Copy is not.
Oh, I wonder if because it's a shared terminal?
I mean, I've been.
Oh, you have been copying. Yeah.
Yeah. So yeah, that copied.
Huh.
But that won't copy paste. Huh. That's weird. Yeah, I guess that's the first time I've pasted anything in here. It wants me to do Shift Command V. So okay, so state. This is very hard to read. So state prime constructs the state prime data type. So
let me make sure I'm following where you are.
Oh, can you see the terminal?
Oh, not really, actually. I mean, like, I can, but it's a little bit garbled.
Okay, I wanted to try this anyway, so let me do share terminal. I'm going to do a read-only terminal and see if that works better.
Sure.
Can you see it?
Now it seems I see SC. Yeah, it's loading. Yeah, that seems to be working okay.
Yeah, and then now when I like resize it, it actually resizes.
Huh.
Course, when I reset the terminal, it lost the state. Lost the state. Add source test StateT test exec prime test. Okay, that passes. So then copy this. So I was just trying to talk through this. So this state function is a constructor. It constructs a state prime data type, which is basically a wrapper, an alias around StateT exactly one. And it constructs it with this unit s+1. So it puts a unit into the value place and like this function s+1 into the state. What would you call that? Into the state?
Like slot? I don't know.
The word state now is so like over loaded. It's like hard to communicate. So then when you pass 2 to this, exec prime takes a state prime and some initial state, and returns a new state.
Yeah, it runs. So you're running state, and then you're getting the state value after. So like, you could get the other part of the tuple instead, but it's basically just getting like.
So one thing I was going to try is I could say my state equals this. Then there's no show instance for it.
Right, because it's a function. Well,
Could I do
well,
first and pass it some value? No, I have to pass exec. Interesting.
Yeah. Wait. So my state.
So my state is of type state prime a unit.
Mm-hmm.
That's tricky. Yeah, I don't know that this is like super important, but I understand what's happening basically. So the state prime is a function that constructs a state prime, capital S state prime, and then exec is a way to like get the state value out of it.
Mm-hmm.
So now we're going to do eval prime, and I imagine just like this was basically the same as our regular exec. It just used runState prime. I think this is going to be the same. It's probably not a good idea to just copy paste, but I think I'm being thoughtful about it. So I'm going to actually try to understand it rather than just paste and move on. So
yeah. Does it kind of make sense now that like state and state prime are like more or less like equivalent in some way, right? Like
yeah, I guess the reason, yeah, state and state prime, well, state prime and StateT exactly one are equivalent. I get that now because by implementing this runState prime, we do the explicit unwrapping here with exactly one. So
yeah.
so runStateT is just a more generic version of that, I suppose. It works with any functor. Is that what you're getting
yeah,
at?
I guess I was hoping to draw that comparison between just regular without the T, like state,
regular state
prime, and state, because like
right.
if you're just using like these combinators or whatever you want to call them, though, with that, like without dealing with like the like the underlying representation, which happens to use exactly one, but like exactly one is the same as like you can always go
identity.
Yeah, so you can always go between like, you know, A and exactly one of A for any A, right? Like you can always go back and forth between them. So like in some sense, exactly one is like it's not really doing anything. So you can kind of think of state prime in that sense as like, since state prime is StateT exactly one, well, StateT S exactly one, you can think of it as like as essentially a, well, it ends up being like a different representation of like of what you had defined as state before, but it's just it has the same exact has the same exact functionality.
Right. Yeah, that makes sense. No, I'm glad you pointed that out.
I don't know if that was the best explanation for it, but I'm sure that like that'll come up, because it seems like that's what it's hinting at.
Yeah. So it's just that this our runState prime, deals with this exactly one. Let's see. Okay. So then, so eval prime passes. Okay, so now getT. So I'm going to peek back at get. Okay, so get is just, you just, it's just kind of like constructing a state, basically, with this as the initial value and the state. but we're going to do a getT. So we just basically need to construct one of these with S as both the value and the state, but then we need to put it in pure.
Yeah, I think that works.
Test getT test passed. Okay. Yeah, that one made sense to me.
Cool.
putT. So in regular state, putT was a way to take some state. Yeah, basically just to manually update the state. I don't know if manually is the right word, but so you have some initial state 0 and you just want to replace it with 1.
Yeah, you're just like disregarding.
Yeah, throwing away the old one, sort of. So that's Let me look back. Did yeah, so I imagine it'll be very similar. So take an S. We want a pure unit, an S. Is that
right? Close. I think, well, there's a little bit of syntax error, right? Is you need like the lambda or like the
right.
slash.
Right.
And you also, so now you have two S's in scope, right? It's like
right,
one's just shadowed.
So I just want to disregard this one.
Yeah, exactly. Yeah.
Which is why the other implementation had const, I believe.
Yeah.
Put T test. Okay, cool. But I guess we can't do the same kind of const thing because it's you could F map it, right?
I don't think you have to. I think you could just put const there.
Okay.
You just need more parentheses. I think it ends up being more characters with const. Yeah.
Okay. So. But yeah, we could just put const here and a $, basically. Because const is just going to throw away some argument. Okay.
Yeah.
Distinct. Oh man, this one was pretty rough. maybe now that we have the benefit of having done it already, that will help.
Yeah, I didn't stick around. I don't really know what this does.
Yeah, I mean, yesterday it was like over 4-hour stream, so I would not expect anyone to stick around that long. I probably shouldn't have done that. I just lost track of time. But distinct, remove all duplicate elements in a list. So we have no like simple examples. These are just prop tests, but I suppose you could, let's see, is it in scope? Oh. Okay, so let's try giving it a list with some duplicates in here. Yeah, so it takes out the duplicates.
That's
and
cool.
It does that by, this took me a long time. So we're using filtering, which itself was a difficult exercise. Maybe I should look at filtering.
A to K, boom. Listed A. Okay, listed A.
So filter, is filters should be pretty obvious. So filter just takes a predicate in a list and just returns the elements that match the predicate. Filtering has some kind of effectful predicate.
Right.
So if we go to applicative filtering, so like a filtering exactly one composed even. So this, oh, I forgot I have to do a different hotkey. Okay, so this predicate checks if it's even and then wraps it in this exactly one context. Which this maybe is not a great example because like why would you do that? But
that's interesting.
This one maybe is better. So if a is greater than 13, then empty, else full a less than or equal to 7. So in these examples, you can see if all of the elements, basically it returns all the elements less than 7.
Right.
So here, this second example, goes beyond 7 and it's less than or equal to, excuse me. So this one includes 8 and 9 and then it filters those out. This one extends above 13 and it returns empty. So this, this initial effect, it's like it's the optional context. So it's saying if any of these values go above 13, then we bail on the entire operation, return empty. So that seems really complex to me. Like, do people actually use this in practice? I'm not sure, but
I'm not sure either. So it's filter M.
Yeah,
it's basically the same thing.
It's called filter M and vanilla GHCI.
Yeah.
Okay.
And I think that the PureScript book had me implement that too.
Yeah.
Recently. But I'm trying to remember how it presented it.
Welcome back to the stream. Sorry, Pete.
Oh, no worries. Yeah, I don't remember. And I think I might have looked it up. To see
filter.
Well, in any case, I'm not sure. I haven't personally used it. But
yeah. So we're just talking about how this filtering function is it seems pretty powerful, pretty complex, but pretty powerful. And then the reason we were talking about that is because this in the state module we did last night, this distinct function, which I think I did an example. Yeah. Which it removes duplicate elements. It uses this filtering function. So basically it filters A's with this predicate P, where P basically is this state which checks if the current state, the current element, basically, if it's not a member of the set, then filtering is, well, then it would return a Boolean, and then filtering would, so if S not member returns true, then filtering will add it to the list to be output. But then the effect we want from our P is to insert the element into the set. So it's kind of doing two things at once, right? It's checking if we haven't seen this element yet, and it's also adding it to the set of elements we've seen so far, so that on subsequent runs, it will check and say, oh, I've seen this too, and then return false, and therefore not add it to the list. And then our initial state is an empty set here. And then one thing that came up is this first repeat function. So if I do, instead of distinct, I say first repeat. this will return 2 because 2 is the first element that repeats itself. But it returns an optional because there may not be any element that repeats itself. So that would just return empty because none of the elements repeat. But look at the implementation of these. Literally the only difference is between first repeat and distinct. Now I guess this uses findM, doesn't it?
Mm-hmm.
Uses findM instead of filtering. But it also uses member instead of not member.
Mm-hmm.
But it's just kind of weird how these are so similar, which I'm sure is why they had you look at it. But findM is like filtering. You know, find is like filter but return the first.
Right.
Like I think even that implementation of it is like run filter on a list and then return the head. That's how you implement find. So findM is like very similar to filtering because it has some effectful component to it. Anyways, why am I rambling about this? Because we're about to implement distinct prime. So basically I was just pointing out that to say like we're building a serious ladder of things here. I feel like it's like Ultron or something, all of the Power Rangers like coming together.
Essentially, the PureScript book has you implement filter M, which like filtering is the same thing, but it has a monad constraint on M instead of an applicative. But it doesn't need to. I don't think I think maybe it's just easier to. It's probably maybe easier to implement with like do notation, but I don't know. That's not too bad. What you have there, it doesn't seem too complicated.
Yeah.
Lift to be maybe a little bit. But anyways.
Yeah. Okay, let's take a stab at this distinct prime. Count Oren, if you're lost at all, please just ask any questions or whatever. So distinct prime. So it says use filtering in state prime. So I mean that's how we did distinct, is we did eval. In fact, I'm going to cheat a little bit. Because it's hard enough, man. It's hard enough already. So A's. Count Oren says you have do for applicatives too. Is that true? Can you use do notation for applicatives? I don't know if that's what Count Oren means.
Yeah. Yeah. So if you don't have like if all you have is an applicative instance, there's an applicative do like language extension. I don't know if that
interesting.
Yeah.
So what does it use, the back arrow?
Yep. So you can it's like so this is like another maybe intuition for like the difference between monad and applicative is like if you have like a do block that has a bunch of like M of A bound to A, M of B bound to B, and if you're not referencing any of the hard to but like if you're if you have like this do block where you have A, M A, B, M B, C, M C or something
like you can do it in an applicative style, right?
So this is like
bind. That's like a monadic way of doing it.
Yeah, but it's this would only need like this isn't really taking advantage of the monadic instance for whatever this M might be. This is like super pseudo code, but like because I'm not referencing any bound variables like in the next computation. But if this needed to make use of A, now this is definitely monadic, right?
Right.
But this is just you could do this with in general prefer not to use do if possible. Really? I've heard people prefer do even for cases like this where you're not really technically you don't need bind. Like you could do this with like this is like lift A3. This would be the same thing as like a tuple section over MB MC.
Right. Yeah. Yeah, I can see why you might prefer do notation over that.
Yeah, I don't know.
That's funny because this actually kind of circles back to what we were talking about with why the applicative instance of StateT like requires monad, right? Because you were just touching on how like if you ever need to make use of this A outside of its context, then like now it's not applicative anymore. And that's exactly what we were saying with the state, right? Is like you can't have access to the state. It's always like an MS. I think Swarm Collective said like, yeah, I like the comments that without the monad, you end up with MMA. Yeah, there's no way to get at this with just apply. So basically, the do notation, if this was applicative, it's just saying this. Okay. That's really cool. So I'm going to put a note here. Do notation for applicatives. So is this a language pragma or extension? Like that's
it is.
That's not in regular Haskell.
Yeah, I think it's called applicative do.
Okay.
It's the in this isn't a pure script course, but like in pure script it's like a do blah 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 in instead of it's like got its own syntax. But I believe in Haskell it's just do, and then yeah.
So in pure script it's a do.
Yeah.
I'm like trying really hard not to make a much ado about nothing joke.
Yeah.
Oh man, sorry. Bad jokes. Count Oren says, I think a good analogy will be will you use flat map over list if you just need to add one to each element? Yeah, I guess you would just use map, right? So is that what you're getting at?
I'd imagine. Like, yeah, like you don't need to use a more powerful whatever operator or
right. Like you could use fmap on list, but
like you could
use map.
Yeah, and you can always like implement map in terms of flat map, right?
Right. Yeah.
Like you can always recover.
Anything that's more powerful or more generic, you could make more specific, I suppose. Okay, so let's get to this distinct prime. So I copied this. Yeah, this is going to be cheating a little bit, but let me think through this. So, but this needs to be a state prime, and we can construct a state prime with this. Could we also construct one like this? I suppose not.
No, because that's
like this.
Yeah, so that the type alias doesn't give you like it's not like a type. It doesn't give you a data constructor for It just gives you it's just the type alias.
So but the type keyword is like an alias, like no doubt about it. Okay, that's kind of a weird type. Like it's kind of weird to make this keyword like it kind of feels like they should have made it type alias then.
Right. Yeah, there might be like I think there's probably a.
Yeah, it's not.
Somebody's definitely made that argument, I'm sure.
Yeah. Account Orange says you can define flat map with map too. Huh. Actually, we might have done that in the list module. I can't remember. Or we might have had to use fold. So to build a state, let me remind myself what the type of state prime is. Did I lose scope on that? Oh no, fat finger.
Yeah.
Load source course. Also, P, I don't want to hold you hostage. So whenever you need to hop, please let me know.
It might be sooner than you because
yeah, no, that's fine. And yeah, I don't know if I want to really make it through all of these. I think I made that mistake. Yeah, there's quite a bit more. So
I think it'll get easier, but yeah, let's set we should go for let's see,
one more, two more.
Unpin. Yeah,
or
I think we can implement I'd say we shoot for let's implement we get down to like optional T and maybe implement functor for it. I can stick around for that.
Okay,
for sure.
Let's try it.
Yeah, I think right here what you're getting, like I would look at the type error actually that you're getting right now.
Okay,
all right,
reload. So
it still says variable not in scope P. Really? Oh, is it not saved?
Yeah, it's not saved. Reload. Yeah, so it wants yeah, I think I need to remind myself with the.
I think.
Why is that not in scope? Because this isn't compiling.
I don't know actually why that's not in scope, right? Oh yeah, probably because it's not compiling, I guess.
I think like maybe if I use defer type errors or something.
Yeah, I'm not really actually that familiar with these, but you might be able to get away with yeah, I mean like using the hover on
yeah,
but like it's not as nice because you have to like but so filtering
so StateT, I was going to build up a state. It's because this says use filtering in state prime with data set. So I was going to build up a state prime with this state prime function.
Yeah, I think that part's good.
This matches that signature. I guess I was just.
I'm pretty sure that part's good.
I think you're right. Okay.
But there's something else that's just slightly. I'm pretty sure that the thing that you're missing is very small.
Oh, I just need to add this expected type list. Oh, so this A's isn't exactly 1.
Yeah, so that's right, because your actual type is what you want. I mean, it's just expanding the type, so it's saying that it's StateT. But what does it say the expected type is? Or sorry, the expected type
is a regular state.
Right, without the prime.
Yeah, without
so
the
like
prime.
It's inferring that from something.
Oh, right. Because we're not using filtering prime, or
I don't think that should matter. Yes, exactly.
Yeah, that's maybe one of the problems of using those primes. Yeah. Test distinct prime test. Is there not a distinct? Oh, I lost the scope on it again.
Yeah, I can't help you. I don't know what the have you ever used GHCID? Like not IDE, but
no, but
just GHCID.
I was watching Gil Christian's stream, he's a follower, and he's also streaming Haskell. I was watching him earlier today, and he was telling me about it. It's like it's like an auto runner, kind of.
Mm-hmm.
Is that right?
Yeah. So you give it like a module, and then you give it like a test, like expression to run, and it just like kind of it does the reloading of GHCI for you, and just
okay. So it's kind of like a TSC watch or a yarn watch kind of thing.
Yeah.
Where
yeah.
You get TypeScript to like just recompile on file save.
Yeah. And like some folks use it as just like their only, like that's their Haskell IDE. Oh, yeah, or like it, like that's how they develop with Haskell, because because I think that Haskell tooling has historically been kind of a mess.
Okay. I mean, that's kind of part for the course, right?
Yeah, I think
most developer tooling is kind of a mess.
Yeah. I think Haskell language server is like a huge improvement.
Yeah, I'm impressed with it. I mean, because I started messing around with Haskell like maybe a year or two ago, on and off, and just in a year or two, it's been dramatic improvement. I would say, at least my subjective experience. Yeah, so distinct prime works.
Cool.
So then remove all duplicate elements in a list. So this, I mean, like we were saying before, eval prime is pretty much equivalent to eval. State prime is pretty much equivalent. So it makes sense that distinct prime would be like pretty much equivalent to distinct. So distinctF, remove all duplicate elements in a list. However, if you see a value greater than 100 in the list, abort the computation by producing empty. Use filtering StateT over optional. Okay. So that kind of reminds me of that filtering example where it says like if A is greater than 13, then empty.
Right.
Swarm Collective asks, have you tried using the doc tests embedded in the file? The VS Code Haskell extension is inserting the refresh and evaluate links. Yeah, it doesn't work for me.
Oh, really?
Yeah. I think
like
there's actually an issue on the FP course like repo that just says like, yeah, it doesn't work. Like close the ticket. I think. Wait, did you just do that or?
I deleted it. I deleted it.
So if you delete it, and then you click evaluate.
When I click evaluate, it says the host doesn't allow running this command. Ask them to enable it. But if you click evaluate, it doesn't do anything?
Yeah, well, when I click evaluate, I have a little tooltip in my bottom of my screen that says evaluating, and then it goes away after a second and then disappears. So like nothing happens. Let me check my logs. Output. Haskell. Finish.
Yeah, there's also a way. There's also a way to like run doc test as like a
yeah.
Well, we don't have to get into it now, but
Swarm Collective asks if I've installed doc test. I probably have not, but I just do stack install or cabal install.
It might be a dependency on this project. Let me see. Are you using cabal here? Packages is dot.
I'm using stack, but I probably
I don't see a package. Right. I don't see a package YAML. How are we even running this? Oh, FP course with cabal. I don't know.
Yeah. I say let's not focus on that. I'd rather do the but I will look into that off stream, I think, because that would be helpful. Thanks for bringing that up, Swarm. Can I call you Swarm? Swarm Collective. distinctF. So we need to have this like effectful check if any value is greater than 100, and then abort the computation, return empty. Use filtering StateT. So So I mean, I'm tempted really to just modify this one again. Is that a bad idea?
I think it's, I don't know. I think it's fine.
Okay, but I don't need I shouldn't use eval prime. I should use evalT because we're dealing with StateT.
Right.
StateT. And then actual type bool list A instead of optional list A. Yeah.
Right. So I think I'm more lost than you are.
Okay.
Like, so px
is this predicate for filtering.
Right.
So then S would be like the current element in the list that we're inspecting.
Mm-hmm.
So we need some check here.
But this has to return a state, like there has to be some other, like, what's the K here? What's the argument monad? You know, that this gets applied to. Is it option?
Yeah,
I guess
it
optional.
should be optional, right?
So
then this predicate should return an optional bool.
right. Wait, this predicate it should return. Well, it should return a state T option, like a state TS optional bool, or no?
Yeah, I think maybe I shouldn't have just like thrown the.
No, I think you're on the right path. It's saying to use state T over optional. Yeah. I think we're like, what happens if you put optional right here? But that's not.
The actual type is bool, and it should be. Yeah, but the actual type is a tuple, and we just need an optional list A. Oh, I think I get it. I think I get it. So we need to return an optional list A here. And I think we just need to say if S is greater than 100, then we return empty. And that's an optional list A, empty. Else we return a full so we do need to return a tuple here, right? So
I think yeah.
So I think what I'm going to have to do is like I'm gonna have to, well, I'm not completely sure. But my intuition is telling me like we do need to do this check. Like if S is greater than 100, we return empty. Else we return a full list. Or we say
list.
But filtering does the appending and the building of the list for us. So we just need to return a K bool here.
Right.
So we need to return a full of whether or not we've seen S. before because we're getting distinct. So then we need like a s dot not member s and then x, or is it x xs? So like here, so you check if x is
Right.
the element and s is the set.
But the thing here it does have to be a tuple, right?
Yeah, it does. So
I guess I'm yeah. What would the other part of the tuple be? So
it has
you're
to be the set, right?
right. You're adding to the set, so you're just doing are you just doing the same thing?
I think so. So my hotkeys are not working. It's so frustrating. So I think I would do s insert x s, and then empty here would also be empty. I mean, we're going to duplicate some code here for a second, but I think we can reduce that after the fact. So maybe this isn't.
What's the type of this though? Compared, like this is a pair of optional something and a set.
Yeah. And then this other one. See you later, Swarm. Thanks for joining.
Later.
Yeah, I think I'm kind of grasping at straws, to be honest.
Yeah, I'm not like I'm not sure either, but like I feel like we were on it seemed like this like I like this a bit better when it was just empty, because then you've got S, and then on the other side of this arrow you've got an M of, or like a K of something, even though this K, like in this case it's empty. In this case it's not type checking, but I'm not sure. But okay.
StateT has to return like an S to a tuple, right?
No, it's an S to a tuple inside of a context or whatever, like a K of a tuple. Right?
Oh, so we need a full tuple.
Yeah. Oh, so there's just some parentheses that needed to happen, right? Or no, still doesn't like that.
Redundant bracket.
I got rid of the redundant bracket, but there's still something up here. Use flexible contexts. Like whenever it tells you to use flexible contexts, you might not. Is that a bad sign? No, I mean, well, I don't know. I mean, like, I wonder if this is okay. I guess what we could do is just like explicitly type this, just so we know that this is the thing that we wanted to, like, it might be like inferring that, you know, it thinks that P should be a different type based on what's going on up here. I'm not sure.
So the terminals, when I run it in the terminal, it says non-type variable argument in the constraint num. So.
Oh, if S, so S is a set. So you're saying if S is greater than 100, that doesn't make sense.
So it should be X. That should be X, because X is the element.
Right. Okay. That whole thing type checks now. But is that right?
distinctF test. Passes. Oh man. That's a bit of it's a bit of a mystery.
Yeah, so, I can't say I don't think I understand it, but I'm glad that it worked out. So putT.
So yeah, I think I mean I'm cheating a little bit because I've done this once before a while back.
Yeah. Empty else full. Yeah.
So So let me try to explain it. So filter has a P and its predicate is a value to a bool.
Mm-hmm.
Filtering has a predicate that's a value to a K bool.
Mm-hmm.
So with filtering, you can have some effectful predicate. So you need to return a bool, but like if the bool inside of the context is true, then filtering knows to add that to the list.
Mm-hmm.
But if there is no bool in the context, like in the case of empty, then you abort the operation because P returns a K bool, not a bool. So what we're saying is our predicate P takes an X, which would be an element of the list,
Mm-hmm.
and then S is, so we pass in this state T. Well, I guess state T receives this empty. The first time it receives this empty set, right? And then we're saying if the element is greater than 100, then we return empty as our K bool. So at that point we just cease filtering and we just return empty, like in this case. But if X is not greater than 100, then we return a K bool. It's not a K bool, it's like a StateT bool, right?
Right. StateT. Yeah.
It's like a StateT S.
Right. So the state
or something.
Yeah, the state is the set that you're accumulating, and then the
this
value,
is the bool, whether or not this element has been seen before, like if it's in the set that we're accumulating by doing this. That's pretty cool. It's pretty intense.
Yeah, I feel like I'm getting a better understanding of like state here, because this whole thing is like a state. Wait, it's a state T of, and then S is set of numbers or set of, so state T, set of int, optional list. Wait, optional.
So filtering,
list
let's
of...
look at the type for filtering.
Yeah, if we're like, all right, so I can see it right here. All right, so
if I hover, will it show it?
Yeah, so it's that. It's probably better on different lines.
Right.
So if we fill in applicative K is state T. So let me just think about this. K, actually, I'm going to duplicate and then fill in. So like if K becomes state T set num, there'd be some kind of number, but let's say it's an int, which is probably, it's,
and then
maybe too much, but like
optional, or is it list?
Yeah, optional. And that's what, all right, so that's what K is, right? Because there's an applicative instance for this, which is crazy. Like
A is a list of int.
Yeah. A is a list int.
Wait,
wait, no. A is just a
state T. So state T is SKA. So S is the set, K is optional, and A is A. So state T takes 3 prems, right? So the third one would be list int.
Yeah,
is that a valid A?
Actually, no. A would be int, but the applicative. So if you were going to fill in K with something,
I see what you're saying.
It would just have to be like partially applied.
Right.
So so now like we can replace K with this mess.
Option. Oh, okay.
Um,
That whole thing.
Yeah.
Jeez.
Weird kind of. Whoop. And then
So yeah, the
again,
predicate
here.
returns a StateT set and optional bool.
Yeah.
This exercise is kind of mean. To be
And
honest.
then this becomes int, which is not too bad. All right, so yeah, I guess it's an A. Yeah, but that's like cool behavior, like that you can, like go through this list. Actually, what does it do?
So it gets all the distinct elements out of a list.
Okay. And then it also has this like it can also do some logic about like, oh, like it's like you're adding like some ability to abort that computation, which is cool.
Yeah.
Yeah. I don't know. I mean, I'm trying to think of when I would use this, but
yeah,
but that seems cool.
It seems like yeah. It seems like maybe it would be easier to just do distinct on some list and then afterwards go through the list and say, are there any greater than 100? And branch afterwards. But you know what I mean? Like why ball all of this up into one giant thing?
But yeah, I guess you only have to
you'd only traverse like once rather than twice.
Yeah, and I kind of struggle with like thinking about ways of doing that, like because, well, yeah. In any case, this is neat. Like you can kind of bottle a lot of logic up into something that is just going to be like pretty efficient in the sense that it's just going to give it like one pass.
Yeah. Yeah, that's fair.
Yeah.
Yeah. Well, I think maybe we should call it a night there. That was pretty brain melting. And we're about to define a new data type. So I think that's a good place to call it quits. What do you say?
Yeah, sounds good to me.
Man, that was epic. Thank you so much for joining me. And I think that was really helpful. It was a lot more fun for me actually to to have another human to talk to rather than a chat box. So I mean, I know that there's humans out there, but real time communication.
This like StateT, like for listeners, so I'm glad that I don't know. I've definitely I definitely learned some stuff here too. So this is cool. I feel like with StateT under your belt, like and like getT and putT, like like you could, like if you want to, like or we can do this at some point, but like you can kind of like make like a little, like, I don't know, like a simple little command line like little game or something that is stateful and like has like a loop or something. It's kind of like how I would think to use like that'd be like StateT with IO as the K.
Okay.
It's kind of interesting the different behavior you get like with list as the K, and but that's cool.
Yeah.
Or
it's
optional.
It almost like that was going to be a really tortured metaphor. I was just going to say like, oh man, this is so nerdy, but like, like those, like that eval Pokemon where it's like you give it a water stone, it becomes like a Vaporeon. If you give it a fire stone, it becomes like the Flareon or whatever. It's like the different that's so nerdy. Wow. But the different types you like pass to the StateT like has different effects.
I'm not
super tortured metaphor.
I can't say I fully appreciate the. I don't.
Okay.
I'm not very. I don't really know
No,
Pokemon
that's
at
all
all.
right.
But I'll take your word for it.
Yeah, it's just like, I mean, there's any number of cartoons or like superhero kind of shows where it's like, there's like these different modes of operation, or it's like once you apply this thing, then like the powers change.
Right. Yeah, it does feel like that. Yeah.
So
Cool.
well, yeah, thanks again, Pete. And if anyone out there is still watching this, if you enjoyed this, make sure to subscribe to catch the future streams where we'll go through the rest of StateT and eventually compose and whatever the contravariant and all kinds of eventually JSON parser. So yeah, and make sure to check out Pete's stream as well. And yeah, thanks again, man. I guess we'll call it a night, and let's do it again sometime if you're up for it.
Yeah, sounds good.
So,
Been my pleasure, for sure.
All right, signing off.